All right. I realize, but we actually have only 2 more weekends for the exam. Yeah? So those of you who sitting there feeling like you have a whole year, this weekend coming up, next week, the exam is on Monday after next week. We can do the month. 2 more weekends, mock exam and the exam is, no, not the Monday, Friday, sorry. Friday. Exam is the Friday the 9th of May. All right? So we really have 2 more weekends, 2 more Saturdays. Some people come to the mock exam. Yes? Don't come on the Saturday. Don't come on the Friday. But first, we're going to turn up for the first mock exam. One mock exam they do. Another problem that I have is that you are supposed to be doing 2 mock exams on a Saturday. You're supposed to be doing 4 papers per week. Minimum. 2 on the weekend and 2 during the week. Some persons only doing the 1 on the weekend and the 1 during the week. They're doing half the number of papers that they're supposed to do. Yesterday, for example, I gave 6 papers. 3 paper 2s, 3 paper 1s. Some people only end up doing 1 out of the 6 papers. 1 out of the 6 papers. For whatever reason. No matter the reason right now. The fact of the matter is that is what happens. Right? Then now, when the exam results come out, everybody got act surprised. Everybody got act surprised. And say, oh, come them doing there, so when some other people doing there. So. Let me tell you something. There is a direct correlation. Talk about direct variation here. A direct variation between the volume of work that you do and the grade that you get. It's almost automatic. And the more work you do, the better your result. That is why Mr. Shah gives so much work. Because I know that that is the direct relationship between results and work. Other things being equal. Some persons don't need to do as much work to get the grade 1. But the background is good. The background in the subject is good. So they are relatively ahead. Right? Some persons, because the background not so good, stop talking, please. Because the background not so good. It means that you need that high volume of work, close that gap. And the sad thing about all of this is that it's the people who really and truly need that high volume of work, those are the ones not doing it. And so the people who them get the exam today, they might get a 1 same year, they are the ones who are doing the high volume of work. It's always something that you can't understand. You come class and the giggle, chat, joke, ram. You don't see the seriousness of this situation. And now come out of the paper 2 exam and everybody will feel sad and start crying. When you're supposed to be leaving that for other people to do. You're supposed to come out of the exam smiling. And what's gonna happen? Because after you go and come out of the exam sad. You start sitting already in that attendance for the mock exam. That's how I keep record of those things. You know? When the results come up, we just send it to the parents. See there? Other than mock exam, we do the attendance there. See there? You do 20 or 24 mock exam, you know, do none. I do 1, I do 2. What do you expect? What? You don't put in the work, but now get the result. If you take this thing light and joke on, you now get the result. Stop joking all the time. Stop coming here as if it's a fun day. Stop coming to class and a joke, ram, this everything distraction. Say giggle, laugh, ram. when there is work to do. Some people, by the time I see them, they're not doing no work. Pretending as if they're doing work. Some people are jokers, posers. Pretending as if they're doing work, but they're really not doing no work. Me and I did that. I use me to do this. I'm going to show you the result. You come like it's a fun day, you come when you come class. Some people like them come class just to buy food and eat. Who want to get food before you come class? Some people come like them come here just to take breaks. Every time I look them gone outside. Let me tell you. Historically, I tell you, I have everything for record now. Students who take the most breaks outside. Yes. Fail. Remember a young lady last year, the parents said to me, oh, come she never another class here. Every minute she take break gone outside. Every minute she gone outside. Every minute she gone outside. It's automatic. What going to happen? It's automatic. So we have 2 weeks to go. 2 more weekends. All it's on have 3 weeks. Because you have the weekdays this week up to weekend. Weekdays up to the next weekend. And then another week up to the Friday. Now, the wicked thing about the week up to the Friday is that exams will have started. For some of you, other exams in that week, leading up to the Friday. So we can't even count the week there. Because we have exams during the week. I have to be fully prepared before the first exam. So we not really count the week when we have the exam in it, the Friday. Because some of you have exams from the Monday, go right down to the exam day. So if you even want to do something, you're not available. Because you don't mind upon the other exams. So really and truly have 2 weeks. This week included. This weekend coming, and next week, and the weekend. And some of you will be using that weekend as well to prepare for the exams that will be earlier up in the week of the night. Your exam will have on a Monday, the Tuesday, like accounts and English and all of other exams. They will come before them. So we have to have no fully that will be the leader. For me, and a joke and it's not so much serious. It's not so much serious. And this morning, I cancel my trip to Pennsylvania to go Pennsylvania. I can't sleep this morning. Can't sleep. Can't sleep. I make up my mind and I cancel the trip. Nah, but I send the message to me. I send it to me. Nah, but I all the reservations and so on. And my daughter was supposed to go out there, and I call her and I send her a message to her. Nah, but I go. Nah, but I go Pennsylvania. I was going to go Pennsylvania this week. No, but next week, see so, and I dedicate that to make sure someone there to do what we can do. So you can't come with this joke on business. Laser-fair attitude, like you're not serious. We're not upon that. We're not sure a high intensity of purpose towards this thing. You like to really go after something. You can't take the exam them light. When I talk about math, but at the same thing of all their subjects them too. And the math alone. All their subjects them. So if you now approach math, which is one of the more difficult subjects to pass, because it have a high failure rate. That is a fact of the matter. And like 30% of people do math pass it. 30%. So if you count to my town in and take 30%, then see the few owners supposed to pass it. Party will come in at a program, my program at 90% and more now my pass. But the fact of the matter, you can't take a subject with such a high failure rate. You can't take it for joke. You can't take it for joke. I like to people fail exam and come class, and then come back the next year, You better have fast and say you want to get a better rate and come back. Rather than fail and then come back. I like see people fail come in my class and worse when they come with the same attitude like when they did before. If you approach it one way and get a result, And you come back and then approach it the same way again. Again, same result. If you approach it the same way again. You get a teacher where it's intense. Right? And I push and I'm going to high level America and tell us that this is what you need to gain success in the subject. You know, just take it for granted that you ignore it. You know, the ordinary, we go on ordinary class. People want to get ordinary results, the ordinary preparation. We don't want an ordinary result. We want extraordinary results. So the extraordinary work, extraordinary preparation. On a 2 weeks to change the mentality, them no want to no joke on it. And not joke. Inside you for the next 2 weeks. On have a serious. Man, I start the foolishness, man. Can't bear it. I know what the result of a wet of a card. You know wet of a card. See, the class start on the outside, see me. Why am I come call? I see people all the time. That's the next problem. See people all the time. That me I run it down for doing own work. Because me I do exam. You don't do my exam them long time. And me I do exam. I will not do exam. Yeah, man, stop the joking around, man. Now 2 weeks left. 2 weeks, including this week. You have to do assessment that weekend. You have to do an assessment this week. Wednesday and Thursday. You have to do an assessment this week. I'm going to do an assessment next week again. So I see we need to drape up. I tell this thing to a joke. Man. Man, pass exam. You have to do so work for pass exam. More work you do, the better. If you can't come Saturday and you come Friday, do everything for the Friday we're supposed to do. I do it for your own time. This was the paper that we did. One of the papers that we did. Pass mark is 65%. You must that jump up to about 80% next week. That's one have to learn from all of the mistakes they want to make. There's somebody in there yesterday have a problem, man. You know, a problem yesterday, you know. Much things you don't know, you know. You go doing a class, you know, it's strange story, you know. See? What time is it now? 11, almost 11:30. I should not reach yet. Anyway, let's do this. First question. They tell us to evaluate this. Never say use a calculator. Because of that, now you kind of want to do a little bit of work. But a calculator question still. The syllabus you can use a calculator, right? So, there. Electronic calculator. Right? Here on the page. Electronic calculator. So, you can use the calculator. So this question, so must evaluate this and give the answer in standard form. Another term for standard form is scientific notation. So instead of saying standard form, they can say scientific notation. So look out for that just in case. The same thing they're talking about. That's when you have the number times 10 to some power. You must only have one non-zero digit before the decimal. All right? So this is it. This is 3.8 times 10 squared. You can put it in there. Plus 1.7 times 10 cubed. Oh. Huh? No. Times 10 cubed. That's giving us 2080. Standard form, you want the decimal point to be right here after the first non-zero digit. Size of the number can't change. It's a big number. You know, say the times 10 to some power is going to be times 10 to some positive number. This number is in the thousand. The power is going to be times 10 to some positive power. When the negative power is when it's a small number. You can use it as a guide. So how do I get the decimal point there? To get the decimal point there, I can divide by 10 cubed. The decimal point on this number is basically there now. I want it to come 3 places to the left. So divide it by 10 cubed. But to cancel this division of 10 cubed, you go back and multiply by the same 10 cubed. And then this calculation in the bracket will move the decimal point, put it where you want. And so the final result is 2.08. I don't need this zero. But I put it, I don't put it. Same difference. 2.08 times 10 cubed. So when you put this zero and not same answer, that's the answer. All right, that's number one. Next question, so must simplify this. Give me the answer, the fraction and lowest term. Again, because I never say use the calculator, but I just kind of get it a step-by-step like. So I'm going to work out the numerator here first. I'm going to use the calculator and do it. And it's half times, well, half times, basically you multiply these two values. I multiply these. You don't need calculator for that. So this really becomes 3 over 10 over, which is a mixed number. 3, 2, 6, and 1, 7 over 2. When you divide by a fraction, you invert and multiply. So this becomes 3 over 10 times 2 over 7. And then now, you all know, 2 cancels into this 1 time, 2 cancels into this 5 times. And so it's 3 times 1 here, so it's 3. And 5 times 7 is 35. That's supposed to be the answer. If you want not sure, you check it to the calculator. Just put that bit in the calculator just to check it. So let's check that. Fraction half times fraction again 2 over 5 over mixed number 3.5. And that is it. 3 over 35. So you're good to go. All right. Next question. Express this in binary numbers. All right. So this is something you don't see a lot often on CSEC. But I teach this in a first form, high school, grade 7, binary numbers. So I know you're not going to remember. All right. So let me just do a little quick thing on the binary numbers. So to the binary numbers, we're really working with place values. Right? In the decimal system, the place values are 10 to the 0, 10 to the 1, 10 squared, 10 cubed, and so on up this way. Those are your place values. In the binary system is base 2. So your place values are 2 to the 0, 2 to the 1, 2 squared, 2 cubed, and so on. What are these values actually equal? 2 to the 0 is 1, and they keep multiplying by 2. 2, 4, 8. These are your place values. So to form this 6 is in base 10. Express the number 6. 6 is in base 10. So you want 6 in base 10 equal to some number in base 2. What is that number? Base 2. All right? So it's basically how are these numbers? How these numbers add up to the 6? That's what it is, you know. How these numbers add up to 6? You're going to use these numbers 1 or 0 times for them to add up to the 6. So reading from left to right, the first number that can go into 6 is this 4. So it's almost like you're saying you're going to use one of the 4s. I'm doing the base 2 here, so now these are just the place values. PV, meaning place values. These are your place values in base 2. You're basically using the 4 one time. Now, if you use the 4 one time, you have 6. And you use the 4, you have 2 left out of the 6 to use. You can use this 2. You're going to use the 2 again. So after you use that 2, you're done. You use up all of the 6. You have accounted for the 6. using 1, 4, and 1, 2, that up to 6. So you're not going to use anyone to put a 0 upon the 1. And that is base 2. This is now 6 to base 10 equal this number to base 2. Yeah? Go right again. All right, I do one with another example, another number. All right. So let me divide the page and think. I want to maybe do an example that base 5. I'm going to show you the similarity. I can maybe ask you a base 5 question. All right. This is what I'm teaching grade 2. The important thing when you're doing base, whether you're going from decimal to base, base to decimal, place value. Writing down the place value. Work with the place. Now, some teachers teaches one rote method to do it. I don't like the rote method. I like the way you understand that you are using place value to get the number. All right, so let me do another example. I'm going to use a different number. Let's say we're using, let's write the number 27. Let's say we're doing 27 to base 10. I'm going to get that to some number to base 2. Let's use 27. Another example. I want 27 to base 2. First thing again is deciding how many of the place values you're going to use to make up the 27. That's what it is all about. So because it's base 2, the only number they can have is 1 or 0. If it was base 3, the only number they can have is 1, 0, 1 or 2. It was base 3 you're working. You're working in base 4, you can only use 0, 1, 2, 3. In other words, you can only use the digits that are 1 less than the base. So if you're working in base 5, you can only use the digits 0, 1, 2, 3, 4. Just like in our decimal system, which is base 10. The digits you use in base 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the digits in base 10 now. If it's base 7, you can only use the digits 0, 1, 2, 3, 4, 5, 6. In base 7, number 7 exists in a base 7. In a base 2, number 2 no exists in a base 2. In base 3, number 3 no exists in a base 3. In base 5, 5 no exists in a base 5. So those are the digits you can use. Always 1 less. If I go in base 10, the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you represent the number 10 itself, I will put 1, 0. Represent 10. The digit 1 and the digit 0 represent the number 10. There's 2 digits they use to represent the number 10. These are 1 and a 0. All right? So let's do this in base 2, this number. So the first thing I want to do is put on the base value, put on the place value. There's 2 to the 0 and go this way. Then 2 to the 1, if you like, you can put on the 1 first and then keep multiplying by 2. The first place value is always 1. Any number to the 0 is 1. So these are the place values. 2 to the 0, 2 to the 1, then 2 squared, then 2 cubed, 2 to the 4th power, 2 to the 5th power, and so on, depending on the side of the number. What are these values actually equal to in our normal system? What are these values actually equal to? You want to see what they are equivalent? This value will be a 1. This value is a 2 in our system. So we understand them to be. This value is a 4. You keep multiplying by 2. This value is a 8. This value is a 16. This value is a 32. I don't need to go any further because I want a value that is less than 32. So I'm not going to be using 32. So these are your place values in base 2. You're seeing now how many times you use these values to make up the 27. That's what you're basically trying to do. You're trying to use these numbers to add up to the 27. And you can only use these numbers 0 times or 1 time in base 2. That's why we're going to do an example for base 5. You can only use the numbers 0 times or you can use it 1 time in the base 2 system, in the binary. So watch me. start from the largest number that you can use. The largest number that can go into 27 is 16. We're going to be using a 16. Somebody might use and somebody in here log into this thing that we use them. All right? We're going to be using a 16. So 20, so you want to see how much you have left. You're using up 16 out of the 27. So you want to see how much you have left. So 27 minus 16 equals 11. You have 11 left to use. So the 8 can come out of the 11 as well. So you're going to use that 8. You put on a 1, you're going to use that 8. You subtract the 8 from this. We're going to use that 8. You subtract the 8 from this. Means that we have 3 left to make up 27. So 16 and 8, you have 3 left to make up 27. Now 3 can't come out of this. So we can't use 4. You put a 0 on the 4, you can't use 4. Out of the 3, we can take out a 2. You're going to use a 2. You take out a 2 outside, bam. When you take out the 2 out that you're using, you have 1 left. And clearly 1 can't use this one. You're going to use the 1. So if this number was 26, you would not have been using the last one, and that would have been a 0. But understand that? Good. But it is at 27, so you're going to be using this one. So that's the number. So 27 to base 10 is equal to 110, 11 to base 2. That is it. Get me? And if we're working from base 2 to a number, it's the same thing. Watch this now. Let's say me write down a base 2 number. So me write 11001. And put that in base 2. I'm going to create some number in base 10. Same thing again. Put on the place value. The place values again are 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th. How much is it? 1, 2, 3, 4, 5 digits. You need 5 places. 1, 2, 3, 4, 5. Good. Those are the place values. What are the values in those places? This is a 1, this is a 2, this is a 4, this is a 8, this is a 16. These are my place values. And this is basically the same. This in base 2 is basically the same. I use 160. Just write back this now. 1, 0, 0, 1, 1. So it means that I use 116. I use 1, 8. I'm going to add the 8. Don't use no 4. Don't use no 2. Use 1, 1. 1, 1. That is my number. What I got. Use 116 here, so. Use 1, 8 here, so. Don't use no 4. Don't use no 2. I'm use a 1. So the 1 there, so. That's it. That add up to your number. Whatever that add up to is a number now. What that add up to? Huh? 25. There's a 25. We can say this 10. The number here is 25 to base 10. 25 to base 10. We could do a base 5 example now, so we can make the connection. We could do a base 5 example. Right? We could do a base 5 example. So let's say we have a number to convert to base 5. Let's say we have the number, just randomly put on 57 in base 10. More get it to a number. Now to equal to some number in base 5. The ones who are 57 is in base 5. So again, that matter of seeing how many times you use the place values. Remember now, when it's base 5, you can use any of the place values up to 4. You can use 1 of it, 2 of it, 3 of it, no, 0 of it, 1 of it, 2 of it, 3 of it, 4 of it. When it's base 5. Right? What are the place values? The place values are 5 to the 0, 5 to the 1, 5 squared, 5 cubed. But we're going to further than that. Right? So this is 1. Keep multiplying by 5. This is 1. Multiply by 5, we get 5. Multiply by 5, we get 25. Multiply by 5, we get 125. Those are your place values in base 5. Good? Remember, you can use these numbers up to 4 times. 0 times, 1 time, 2 times, 3 times. 4 times. Because it's base 5. All right? Watch this now. Then the number 57. Clearly, we can't get 125 out of it, right? So the question is now, how many 25s can I get out of 57? I'll make it more interesting. Let's change it to 75. Let's change this to 70. Let's change this to 77. Let's just change this to 77. So this number is smaller than 125. So I'm now going to use 125. How many 25s can I get out of 70? And the number still not. Let me change it again. One can put in somewhere. Let me use 89. Let me see changing. Oh, 89. Still, how many 25 I can get out of 89? 3. Don't it? That means I'm going to use 3 of the 5s. You can use up to 4 now. As the base 5 reference. You can use up to 4 times any of these values. So I'm going to use 3 of the 25s. So 3 of the 25 equals 75, right? So I'm going 89 minus 75. But that's why I'm subtracting 75. Huh? I'm not done here. Let me see what I have left there. So after I subtract this, how much I have? 14. Good. So clearly we can't use 2 of the 5s. You can't use 3 of the 5s. You can only use 2 of the 5s. You see that? See that? So we can use 2 of the 5. So 2 of the 5 are 10. So I take out 10 more now. I have 4 left. So clearly we use 4 of the 1, don't it? 4. That is it. So 89 to base 10 is equal to 324 to base 5. That is it. But good. In base 5, you can only use up to 4 times any of the place values in making up the number. Let's go the other way now. So have a number in base 5 and convert it to base 10, right? So let's say we have a number. Let's say we have a number in base 5. I'm going to look at this. So let's say we have the number 1, 4, 3, 6 in base 5. Can that number be in base 5? Can't be in base 5. But the base 5 digits can't pass 4. So this can't be a number in base 5. You see that? The base 5 digits cannot pass 4. So if you give that answer to the base 5, no, something wrong. The base 5 digits can't pass 4. So this could not be a number in base 5. You get me? It can't pass 4. So I put 4 right there. So let's say we have it. Put 1 0 in this. Put 1 0 in there. Put a 0 right there. And then a 2 in base 5. We want to convert that to base some number in base 10. So all you have to do is put these values in the place values, in the place holder, the place value position. What are those place value positions? 5 to the 0. How much position we need? 1, 2, 3, 4, 5. We need 5 values. 5 positions are we need. 5 to the 0, 5 to the 1, 5 squared, 5 cubed, 5 to the 4th power. 1, 2, 3, 4, 5. 5 positions are we need. See here now. This is 1. I keep multiplying by 5 this way to get the values themselves. 5, 25, 125. 5 times 125. Somebody wrote it for me. 5 times 125. 625. 675. 625. 5 times 5 to the 4th power. 625. 625. Remember. So these are your place values on base 5. These are your place values. What this number on base 5 is saying, you're using what you put in the number from this way. So this is a 2, 0, 3, 4, 1. What this means is that your number, you're using 1 out of 625, just one of it alone. So 625 times 1. You're using 4 of this. 125 times 4. Using 3 of this. 25 using 3 of them. None of this. Using 2 other ones. 1 times 2. Using none of this. You don't want to write it into and say using the 5 no time. And using the 1 2 times. That's what you're working on. But understand that? And whatever this works out to know is what this number is in regular number. This number in this 5 will be equal to whatever this works out to in regular number. And that is it. Want to work out to? Huh? 1902. So this is base 10. It means 14302 in base 5 is equal to 1902 in base 10. That is it. I don't think CSEC is going to ask for the more than that. Give you a look at him. You ask if I add 2 numbers. So give you 2 numbers in base 2, for example. 2 numbers in base 2, for example, and try to multiply them. I'm not going to go through a multiplying basis right now. So just to you, convert them to decimal, normal decimal. Multiply the decimal and then convert it back to this. That's what I just said a while ago. Say it again. You give you 2 base 2 numbers, for example, to multiply. I'm suggesting because I'm not going to go through multiplying where you multiply base 2 now in the base. I suggest to you, they give you 2 numbers and operation and 2 numbers to do, and the 2 numbers they give you are in base 2, for example, or base 5. I suggest to you that you convert them to regular decimal number, multiply them in decimal form, see what you get, and then convert it back to the base. And get the answer by here. But good? That is the plan. Let's continue. So this answer right here is 110 in base 2. This answer. So write the answer like this and put it in further. Answer is that 6 in base 10 equal to 110 in base 2. This is the answer. 1 mark per attempt, but it's still the 1 mark. All right, let's continue. This one says, John bought a car for $65,000. If the value of the car is depreciated by 8% each year, how much will the car be worth at the end of 2 years? So depreciation means that it is losing value of 8%. So if the value is reduced by 8%, the remaining value of the car is 92%. But you can understand that? You do have to waste time, calculate 8% and then subtract it. We can just calculate what the remaining value is, which is 92%. If you take off 8% of something, 92% left. You have to understand what that percentage is to make the world more efficient. So it's 2 years we're going to depreciate the car. 2 years. Right? So watch this now. After the first year, the year end at the year end, you know, at the end of the year, they depreciate through the year. So year 1, let's set up like this. Year 1 end value becomes 92% of the original value of 65,000. What you do have to waste time and work that out. You do have to work it out. 92% is just 0.92. That's the first year value. You do have to waste time and work it out. You can use this as your first year value and apply 92% now to this value. And the 92% now is going to be applied to this new value now. But you don't have to waste time and work it out. Because you're really only interested in the year 2 value. So my year 2 end value, what is now? Year 2 end value is now 92% times this, which is 92% times this. Put that in the calculator and you get it. But understand that? You apply 92% twice. But understand that? You do have to absolutely waste time and work out what that value is. You're not getting mark for that value. You're getting mark for the year 2 value. So all I need to do is do the calculation, 92% of this. I don't need to know what that is. The calculator works for me. So put this in the calculator now and you get it. 92% times 92% of 65. That's what it is. That's so nice. So put that in the calculator, you get the answer. You can put 92% or you can put 0.92. Your choice. Let's see. 92% times 92% times 65,000. That's it. So that value right there is 55,016. Again. But understand that? Very good. Let's run. Remember, any question never get right, you need to go and work over there. Come to a young lady. Hello, ma'am. What time to you? Huh? Can't sleep and learn nothing, you know. Come on, man. Sit up. Sit up, man. You have 2 whole weeks, so you must think you can learn in 2 weeks. You must improvement you can make in 2 weeks. You decide to apply yourself and put in the volume of work in 2 weeks. You tell yourself, say, look here, I do 3 papers every day between now and the exam. 4 papers every day between now and the exam. Paper 2 me at all. Commit yourself to that. I'm going to do 4 papers every day. 3 papers every day and spread out the time when you do them. And you say, answer, sir, send me the solution for this paper. I'm doing this paper, send me the solution. I have a solution for every paper. I don't have a solution, I'm working out a fail. I'll give you. Come here, validate. I say, sir, I'm going to do 2 papers. I have a guy, you know, I got my workplace. I don't master. Every day the man come to 3 papers. Every day the man do 3 papers at work. So I'm telling him, don't work after lunchtime. Give that break. After lunchtime, stop work. Go and work here. All right? No, sorry. No, when you come to work, let's go sit down and work here. Now I make him do no work. Now give him a break. He just do 2 papers exam. 3 papers the man do every day. Most pass automatic. And after a while, it's like you're the same question and say one over again. So you still can do it. Commit yourself. My one. Tell yourself, I'm going to do 3 papers every day. Go after it. I'll back up. Yeah, let me move that thing on the screen. Yeah, I can press that thing on the screen for me. Press there. All right, not now. I'll remind later. No, man, use your finger. You can press the screen. Yeah. All right, good. So let's continue, guys. Let's continue. Still on question 1, so we need to pick up the theme. This question says the table below shows the result obtained by a student in her CSEC math exam. It's something like this and use math grade the paper for you there. Something close to this, not exactly like that, something close to this. So the maximum mark for each paper is given the 3rd column. That is the maximum mark. That's what to make up the 100%, right? It said determine the percentage the students final mark in the math exam. So she got 55% on the first paper, 55 of this 30. Then she getting 60% of this 50. Then she getting 80% of that 20. To make up the total, the final mark, right? So she's getting 55% of 30 plus 60% of 50 plus 80% of 20. This is already out of 100, so that's the total mass you're gonna get. It's out of 100. So the mass you get is gonna be a percentage for me. Right? That's out of 100. So let's put that in a calculator. 55% of 30 plus 60% of 50 plus 80%. 80%. Of 20. 62.5. So she's getting 62.5 out of 100. Out of the 100. All right, times 100%. I can put 62.5%. Already out of 100, right? The mark is out of 100. So that's what you get. That's the percentage. Out of 100. 62.5 out of 100 is 62.5%. So that is it. All right, let's continue. Question 1 done. All right, let's move this. Let's see if we can pick up the pace. Go back at early. Or let's finish one question. Guys. All right. This question must make X a subject. Make X a subject. You transpose this over here first and subtract it. We're going to get y minus 3p equals x over 5. That's the first thing we're going to do. And we're going to take this 5 and multiply it up here. We're going to get x equals 5 times everything, y minus 3p. That is it. You can write it here. So x equals 5y minus 15p. I could leave it factored in. Let's leave it factored. Let's leave it factored. 5 into y minus 3p. But we're going to do that simple transposition. Transpose everything away from the x. That's it. This one says, solve this equation. No, that is just 2 terms in that quadratic. So we don't need that lengthy process to factorize. Just 2 terms in there. So it's factorized out. The highest common factor will be a x. X out of this is 2x. X out of this is minus 9 equals 0. So it's either the x equals 0 or the bracketed term equals 0. So the x equals 0 is one answer. Or if this equals 0, can you see that the x is going to be 9 over 2? So the negative 9 carry 2 over and then divide under the 2. But can you see that? Good. X equals 9 over 2. Done. Let's continue. Next part says, a farmer wishes to enclose a rectangular plot with wire fence. With a wire fence. The width of the plot is 3 meters less than the length, L. The width is 3 meters less than the length, L. So I would sketch it. Call this L and call this L minus 3. But that's L minus 3. The width is 3 meters less than the length. What do I understand that? And they tell us that the area is this. 378. That means that this time this equals 378. Let's write it in. 378 meters squared is that area. So it means that L times L minus 3 equals 378. Expand this and transpose that to get the equation. Easy question. L times L is L squared. L times minus 3 is minus 3L. Take this 378 and transpose, we get minus 378 equals 0. Shown. Nice and easy. But good? Nice and easy. Let's continue. And they don't want us to solve it, right? They just ask us to get that. Here's a direct variation, directly. It says the force F applied to an object is directly proportional to extension E produced. It says represent information in terms of Fe and an appropriate constant K. The first variable is directly proportional, meaning K times the second variable, which is E. That is it. All right? Down here now, it says the incomplete table below shows corresponding values of F and E. And I want us to find these two values. This can be done. We will find the K first, or we can do it without finding the K first. Your choice. Want to find the K first? Let's find the K first. So to find the K, we can use this pair of known values, right? Find K first. Let's do it over here. We're going to find K first over here. We don't have to do it this way, but we're going to do it this way this time. Find K first. I'm going to be using this pair to find the K, right? Remember, the F is equal to K times E. So the E is equal, no, so the K is equal to F over E. K is equal to F over E. So the F is 8 and the E is 0.2. So the K then is 8 over 0.2. What that work out? 40. So based on that, we have the formula now. Based on that, we know that F is equal to 40. F is equal to 40. So using it on this pair, on the first pair, where F equals 25 and the E equals X. You plug them in there. So we're going to get that 25 is equal to 40 times X. When you plug these values in this formula. So divide by the 40 to get X, right? So the X equals 25 over 40. What that work out to? Huh? 0.6 so much? 25. And the second case over here, the F is equal to Y and the E is equal to 3.2. So that now you plug them in this formula. So the F is Y is going to be 40 times the 3.2. What is work out to now? 128. All right, nice and easy. Question 2 done. But I go to that. All right, so we could have done it without finding the K first, but that's fine. That's fine. Number 3, use a ruler, a pencil, and a pair of compass. Construct a right angle triangle such that AB is 5, the angle at B is 90, and the angle at A is 60. Sketch it before you construct it. So the AB is 5. I'm going to construct it. Why it's moving slow. This is AB. This is 5 centimeters. The angle at the B is 90 over here. Over here says 90. And the angle at the A is 60. We're going to construct a 60 equation. All right, so constructing this state. I hope you say C. Let's do it. Let's construct it. Who is the construction? A 60 and a 90 one. Right, and I'm moving slow. I don't know what that. Right, tired. All right, let's find this one. Moving slowly. All right, so let's construct this bit. So ruler, I'm gonna draw the 5 centimeter line first. And then we're gonna use The protractor, no, the compass, sorry. Let's change the construction now. I'm going to construct a 60 from this end and a 90 from the other end, right? So the 60 kind of easy. You only need 2 arcs for the 60. We draw 1 arc around here, right up to about where you know 60 would be. Move the point to the intersection to the arc with the line here. Rotate the compass and cross that first one. Line through there is going to be 60. From over this end now, we're going to construct the 90. Construct the 90, we're going to use the method of constructing 260 and bisect the second 60. So we need a big 120-degree arc first, all the way over here. All the way over here. Move the point to here. Cross that first one. That is 60. We'll move the point up here. Wrong place, right there. Cross that second one. They're going to bisect that second 60 on top. Let's change the color. So we're going to bisect this arc on top from this point. Rotate over here and make an arc. Bisecting that 60-degree arc up the top. Arc up there. Come to the other end here. Rotate it. Cross that one. That is it. We need to join those lines now and make them intersect. Here's the block. So draw a straight line through this intersection. That's the 90. And draw another line through this intersection from here to the intersection. That is 60. Across it. That is 60. It means that right up here is C in that intersection. Right here is A. Right here is B. Right here is 5 centimeters. Construction done. Very good? That is it. All right. Next question. Hold on. Hold on. All right. Next question. This question gives us this diagram. The right angle triangle gives us the sides A, B, and C on it. So use the diagram to express C in terms of A and B. That's Pythagoras' theorem. So it's going to be that the hypotenuse squared is equal to the sum of the square of the other two sides, A squared plus B squared. But because them says C, I'm going to actually square root and write C equals square root of A squared plus B squared. Because them says C as if it's just C alone I want to make the something. So I'm giving them this as my answer for C. All right. Next part says, write in terms of A, B, and C an expression for sine theta plus cos theta. So sine theta plus cos theta equal. Now what is sine theta? Turn off this angle. Opposite over hypotenuse. Remember, to this angle, this is the opposite. This is the hypotenuse. And this up here is the adjacent. So the sine is A over C, but the opposite over hypotenuse. So the sine is A over C. So this is A over C. Plus the cos theta is the adjacent the B over the hypotenuse is C. That's B over C. So this one is B over C. The two of them have the same denominator, so this can be written as A plus B all over C. That's sine theta plus cos theta. All right, that is it. Next part says, using the results from part A and part 2, show that sine squared plus cos squared is 1. So basically, you need to work out what this is and show say it's equal to 1. So I'm going to say the sine theta squared plus the cos theta squared will be equal to, now the sine theta was A over C, and you're squaring that, right? Plus the cos theta was B over C. Let me put the square here, sorry. Put the square right here. B over C, and you're squaring that as well, right? So this becomes A squared plus B squared over C squared. Why do I understand that? Because the two of them have the same denominator, C squared, right? But from Pythagoras' system at the top, this A squared plus B squared was C squared. Or you could say this C squared was A squared plus B squared. Anyway you want to look at it. So this then is the same as C squared over C squared. C squared over C squared is 1. Therefore, shown that this equals that. Shown. Therefore, shown. We have shown that this expression is equal to 1 by doing that. All right? So that's how you connect the trigs and Pythagoras theorem to get that identity. So we call that trig identity. When I was in school, you know, there's an identity we have to know and use. You know? Sine squared plus cos squared equal 1. You have to know it at CSEC. But now you have to know it if you do admins. So for CSEC, they ask him to show it. Admins have to know it and use it. All right? That finishes that question. Next question, number 4. So this is a rational function. We did this in class. There are a number of them in class. Question says, find the value of x for the function is not defined, undefined. Also, they could say, what's the value of x for which that cannot work on the function? What value of x is not valid? That value of x that will make the denominator equal 0. You don't want the denominator to be 0. So it is when the denominator equals 0. The function is undefined when the denominator equals 0. That denominator will be 0 if the x is equal to 5, clearly. You can take this minus x and transpose and get x over here equals 5. We can see that if 5 minus x is 0, then x will be 5. So x can be 5 on this function, otherwise it becomes undefined. But the denominator becomes 0, and you can't divide by 0. So x5 cannot be in the domain of this function. 5 cannot be in the domain. All right? So that is that. Then this one says, no, express h to the minus 1. Make h to the minus 1 the subject. Huh? Huh? Yeah, undefined is only when you have a rational function. The fraction one. And the denominator can't be 0. Okay? I can't divide by 0. So for example, I'll give you this. F of x equal 2x plus 6. This is not a problem. There is no 0 to divide. Get me? Not a problem. I can give x any real value and to work out a value. But we have a fraction where the denominator can become 0 for a value of x. You can use a function when x is a value that will make the denominator work out to be 0. The function is undefined. So that value of x cannot be in the domain. Otherwise, the function cannot work. For any value of x that will make the denominator 0. All right. Then I want to find h to the minus 1. So the rational function to do the inverse of, and we did a number of these in class. So I want to start by saying h equals, let's put this again, not a lot. Let's put it over here. H equal, what is it? It's 2x plus 3 over 5 minus x. 2x plus 3 over 5 minus x. The inverse is the same way. Just like the transposition, we have to expand out everything in separate terms, transpose everything on one side, and then make the term that you want the subject. How do you find inverse? Multiple ways to do it. Any method they use, you're going to have to do transposition of this thing. You have to make whatever is in this position the subject. Any method they use. Some teachers teach you where you make the X subject first, and then you make the switch between the X and the Y. I do it a method where you make the switch first and then transpose. So if this is the function, the inverse function would look like this. Where the X is, where the H is, you get X there. And where these X's are, you get H to the minus 1 there. So you get 2H to the minus 1 plus 3 over 5 minus H to the minus 1. Some teachers don't do this. Some teachers will call it Y equal 2X plus 3 over 5 minus X, and then interchange and say X equal 2Y plus 3 over 5 plus minus Y. And then transpose and make Y the subject. You no matter what method they use. Any method they use, the top in other position will be transposed to make the subject to get the inverse. Whichever method they use. You cannot avoid that transposition process. Whichever way you want to approach. All right? So this is how I do it in this class. And day one, let's continue. So I want to know, make this thing the subject. To make it the subject, you have to expand it out into separate terms. You don't want them to be dividing each other. Expand it out into separate terms. Group everything with H to the minus 1 on one side, and then factorize it. And then divide away the factor. So you take this and multiply it by yourself by the X first. That's always the first step. So you can expand out everything in separate terms. So you can take in the X and multiply by each of these terms. So it's X times the 5 is 5X. And then X times this H to the minus 1 with the minus becomes minus X H to the minus 1. That leaves with this on the right side. 2H to the minus 1 plus 3. Then I want to get these on the same side of the equation. But I'm going to put them on the left side. I'm going to put them on the right side. No, I'm going to put them on the right side this time because I want this to come over and become positive. I don't want to have two negative terms over here. That's why. That's all it is. I want to bring this over onto this side with this. Put them on the same side. And then take this over here. You know, I'm going to get, this is staying over that side. 2H to the minus 1. This goes over here, I'm going to come up plus X times H to the minus 1. This stays over this side, is 5X. And then this 3 come over here and become minus 3. Minus 3. Then I need to factorize the H out of these two terms. So I get H to the minus 1 bracket. Out of this, I get in a 2. Out of this, I get in a X. And this stays unchanged. 5X minus 3. And all I need to do now is take all of this and divide it under this side. H to the minus 1 then is the subject. It's not complicated. All you have to do is do it 10 of them or 5 of them. So all you have to do is practice a number. They say that these are the same steps. Just practice a number of them. That's one of our problems. You want to do one example and you say that is it. Practice a number of them until you get comfortable with the process. It becomes like almost like routine. Like almost like routine after that. So you take all of this now, you divide it under here. So you get H to the minus 1 equals 5X minus 3 over the 2 plus X. And that is it. You can write it up here so now in red. We say this H to the minus 1 is equal to this expression. 5X minus 3 over 2 plus X. And then you can put it by the off X when I'm on this. Put it in one, put it in a different color. Put it by the off X. And this is right here the answer. Practice it. Practice it. Once you get a rational function, these are the same steps all the time. All right? Practice it. We do a lot of these when we're doing functions. It shouldn't be strange to anybody, really. Let's continue. That's what it is. You don't practice things. Some things at one point, if you don't practice, it's going to become hard, like you don't remember. You have to practice it. You practice that a lot, becomes like second nature. All right, this one says, the graph below shows a straight line intersecting the X and the Y axis. All right. So, map out the scale first. So this right here is a 1, this right here is a 3, This right here is a 5. This here is a 1, 2, this is a 3, right here is a 4, and right here is a 5. So map out all of that. Go to just be clear on those things before you start. Question said, this line sloping down, so that a negative gradient. Going along this line from left to right, you're going down, so the gradient is negative. Read, pay attention. And that's where you fall. Question says, use the graph to determine the gradient of the line. You just need to check the rise over the run between 2 points. Go from left to right. Go from a point on the left to a point on the right. See what the rise is and see what the run is between those 2 points. All you have to do. So these are 2 known points here and here, for sure. I know what the rise is. We go from this point to this point, rising and running, you have to come down by 4 units. So my rise is -4 because I came down. And then I have to run 5 units here. That's my run. It's +5. The rise or run is -4/5. As simple as that. So the gradient is rise over run -4/5. Don't think it's too easy for the problem. Next one. The equation. The equation of a line is y equals mx plus c when you know the gradient and the c. You have both of them. See the c here? This is the c, you know. And this line now we cross the y-axis, you know. This is the c. C equals 4. And the gradient is -4/5. You don't need no calculation. Plug them in there. So this equation, therefore, is simply y equals -4/5x plus 4. That don't need no calculator. You have the C and you have the M. So it done. Just the exam is easy, you know. Next one. The equation of perpendicular line passing through P. So the line perpendicular, it has a negative reciprocal gradient. So the line that you want has a negative reciprocal gradient. So the gradient of this line is -4/5. The negative reciprocal gradient is 5/4. Flip the one that you have and change the sign. So the gradient of the perpendicular line is 5/4. Now to get the perpendicular gradient, we flip the 4/5. Flip it, it becomes the perpendicular gradient. I'm writing like this. M perpendicular is -1 over the gradient of the first line. And this calculation is like a take the 5/4, then we put the -4/5 and that here. But the quick calculation to this is flip and change the sign. And write out in words. Flip and change sign. Flip and change the sign. Sign means positive or negative. If the gradient up here was negative, the perpendicular gradient is positive, and you flip the fraction. Then it pass to the point P. What's the coordinate of the point P? So can I use it? Pass to the point P. Where's P? P is which point? P is right here. That point is 5, 0. P on this graph is 5, 0. See? This point is 5, 0 right there. So the point P is 5, 0. So on the equation with this gradient passing through this point. So it's in the point gradient format for the equation of a line. And this is it. Y minus the y value at the point equals the gradient into x minus the x value at the point. You have to know that. I call it the BFF when I introduced it the first time. Best friend forever for the equation of a line. Because y minus the y value at the point is 0. Equals the gradient of a line that you want is 5/4. Into x minus x value at the point here is 5. This is just 0, so we don't have to interfere with it. So it becomes y equals 5/4x, so this time this, and then this time this give me 25/4 minus 25/4. That's the equation right there. Easy as that. Y equals that. That's it. You're too easy, man. Burn me, I see them something give people problem, you know. I'm telling the truth, burn me. It's too easy. All right, next question. Number 5. A survey is conducted among 48 persons to find out what mobile network they use. The table below shows the result of the survey. So this must add up to 48. Let me check it. Yeah, add up to 48 for sure. But this one is a 30, and this one is a 80. Yeah, that's a 40, right? So this equals 40, right? All right. Question says, if this information is to be represented on a pie chart, what is the angle of a sector for the O phone right here? It's 10 out of the 40 times 360 degrees. Because the total angle in the pie chart will be 360. The fraction of the total is 10 out of the 48. Easy. 10 out of 48 is a fraction of 360 degrees. That's what they're working on. What are we working out with? How much? 75 degrees. So this is 75 degrees. Don't put it under here. So it's a 75 degrees on a pie chart. And it's a twice as much. Anybody can see that? Now, if we work that one there, no? I want that twice as much, you know. If this is 75, then it's a 150, don't it? And if we find that one at 2 times that as well. That one at 6 and one at 12. See that? Good. I don't know if you need it anymore. Oh, they have to find it. Because the also to do the pie chart. So using the circle below, which has this radius, they want us to represent information on a pie chart. So I'll be doing it accurately on this. So I'm going to do it on the construction with the protractor and show you how you do it. Right? But let's work out these angles first, right? So other would be what? So this is O4, right? O4. This is O4, right? And from the O4, we could have deduced that the wire tech is 150. Let's work out the other, and then by extension, we'll get this one. For the other, do the other in this. So we're gonna say also. I never asked it in other would be 6 over 48, which is what? 1/6, no, 1/4 times 360. 45 degrees. Yeah, 45 degrees. And so this one now is 90 degrees, don't it? All right, so you can put them on. It's a 45 degrees and 90 degrees. That's a twice as much. All right, and this must add up to 360. All right, so let's put it in the pie chart. Let's put it in the pie chart. So I'm going to draw about this funny thing and then put in the angles, right? Let's do this and show you how you position the protractor to be. Everything important, guys. Not taking anything for granted. Everything important. Here is it. Done. That's right here. All right, let's clear. All right, I'm going to draw about that circle first. Draw back a circle first. And then let's say that's up there. That's there, right? And they give us a line like here. But let's say that's what they give us. I want to put in these angles now. I put them in the same order. 150 degrees first. I can leave the 150 for last, you know, as the final one. Put in the smaller one, and then 150 is going to be the final one. You get me? But they don't tell us which one to start. So let's work it this way. So let's go back that way. All right, so we're going to put in the 45 first. We're doing this guy now, right? Put the eye on the point right there. Rotate until the base passes through 0. And then you're measuring 45 degrees from the 0 scale. 0 scale is right here. All right? We're measuring the 45 degrees from the 0 scale. So you're counting up to 45. 45 degrees is right at this mark. You're going to see it right at this mark here. So. But can I get that? Over here, so I don't want to mark up it. Over here, 45 degrees. Right? I'll put that up. I'll put that up. Right? I'll move the protractor and join that line first. The 45 degrees. Draw that line in. up to here, 45 degrees, up to there. Now bring it back to this. That's 145 degrees. All right? Then I need 90 from this line now. I need 75 from that line now. Bring back the protractor and rotate it so that the zero pass through that line now. And then on the zero scale, measure 75 now again. 75 is going to put me, look at it, with the zero scale, inner scale is the zero scale. 75 is going to put me, what's more, 75, put over here. No, not that. God, first line, God. But over here, sir. Good job, Adam. So, line is there. This one. This is my 75 degree mark from that one. So I'm going to draw the line out here and again over here. I'm going to stop it here. 75. If I'm labeling it, this is 45 degrees to the 75 degrees to the other to the 04. Then now from that line, I need 90 degrees now. I need 90 from this. I'll rotate this again now to 0. This line pass through 0. I need 90 degrees. Let me make this a little bit smaller. Can I get that smaller? Yes. I need 90 degrees. The 90 degrees is right around here. So I put this down. 90 degrees. Move this again. Draw a straight line out there. Out to this line. That's for 90. When I finish it off, you know, 90 degrees. Remain now. Last part is 150 degrees. This one is for Digitech, Digilect, that's for VLL, EL, and Wiretech public. That's it. Right? Let's not give away marks on this. That's too easy. Come on. Right? Remember to do it? You need to go on. All right. Next question. We'll do that one over there. This one says, the incomplete exam. So this is the column for the boys, column for the girl. Oh, this one has some standard deviation. All right, we're going to talk about that. All right. The question said, a girl is chosen at random, means that we're coming out of this. We are reducing sample space to just the girls alone. We're coming out of the 250 girls. So this probability is out of the girl. What's probability that we got a grade 1? How many girls got grade 1? 62 of them out of the 250. But the probability of getting a grade 1. So probability of getting and the girls, probability of a girl getting a grade 1. Probability of getting a grade 1 and you're a girl equal to 62 out of that becomes 31 over 125. Good? That's it? 31 out of 125. That's probability of a girl getting a grade 1. Easy as that. Next part says, what percentage of the boys who took the exam got grade 1 to 3? What percentage of the students who took the exam, boys now, got grade 1 to 3? So we need to know how many students get 1 to 3. Oh, all right. So what I mean here now is that they did not tell us grade 1 to 3. Okay, I know the total of the grade 1 to 3 by with these two minus from the 200. But I understand that 200 minus 38 is about. So grade 1 to 3, grade 1 to 3, the total number is 200 minus this 38. What's that work out to? One what? 162? 162, correct. There's 162 out of the 200 as a percentage. See that? The percentage is 162 out of 200 as a percentage. So that it becomes equal to, the answer is equal to 162 over 200 multiplied by 100%. That's like 81%, right? 81%. 81%. All right. Next part says, consider the standard deviation in the table on page 3. Compare the performance of the boys and the girls. 1 mark for this number. We want the 1 mark. We're going to talk about standard deviation again. One last time. You're looking for the one that is higher or less. That's what you're looking for. The one that is of a higher standard deviation means that the grades of the boys are more widely spread from the mean grade of the boys. That's what all it means, as compared to the grades of a girl. The one that has the higher standard deviation is how wide the data spread enough. From the mean, you have to put in the term from the mean. You can give your explanation referencing it from the boys or referencing it from the girls. So since the girls' standard deviation is less, it means that the grades of the girls are closer together, closer to the mean grade. That's what means that the grade of a girl is spread out less. So we said the grade of a girl is more closely spread from their mean grade as compared to the grades of the boys. You have to say from the mean grade. And it's like a comparative analysis, comparing what the boys do with the girls do. So like the girls in another class, the grades them closer to one another. And the boys, the grades them wider from each other. That's what it basically means. But this now is in relation to the mean grade. The standard deviation measures variation from the mean. You have to say that. So you can answer it referencing the boys or referencing the girls. So if I'm referencing the boys, I'm going to use the term more widely spread, because their standard deviation is higher. If I'm referencing the girls is more closely spread from their mean grade. All right? So let's write a statement down there. Right? So if I'm referencing the boys, the boys is 8.2. The girls is 6.3 standard deviation. Higher value, wider spread. Lower value, closer spread. Simple. You want to say the grades of the boys are more widely spread from their mean grade. Compared to the girls. As compared to the girls. Key phrase in this is this, from their mean grade. Standard deviation is measured from the mean. Or I could reference it from the girls. I'm referencing from the girls, using the girls as the reference. I would say the grades of the girl, the grades, any of them to your right them. I'd have to use my exact terms. You can use your own terms. You want to have terms in there like more widely spread or more closely spread. So the grades of the girls, girls are more closely spread. Closer, the grades are closer. and still from their mean grade. As compared to the boys. That's it. Key term again is from their mean grade, from the mean grade of a girl. They don't have to have the same meaning. They have the same meaning. The grades of a girl deviate less from their as compared to the grades of the boy. The grades of the boy more from their mean. They don't have to have the same meaning. Okay? Good. Next question. Question 6. I think we did this question already, but no problem. More math equal better now. We did this question the other day. We did solid geometry. Right? We did this question the other day. Question said, diagram below not drawn to scale shows an open cylinder container made of metal with a circular base and a uniform thickness throughout. So the length of a container from the top of the length of a container from the top to outer bottom is 120 centimeters. That's this. And the inner and outer radii are 14 and 15. That's inside there and outside there. All right, 14 and 15 respectively. Draw the cross-sectional view of the container showing the measurement of the inner and outer radii. We just need to draw two concentric circles, one where the radius is 14 and one where the radius is 15. All right, so that's it. So in terms of draw it, you want to use your arm, the compass to do it. So you want to do it like this. You know, to roller. 14 kind of long still, you know. 14 and 15 kind of long. You can't fit on a screen here, so. So let's use 7 and 8. Half as much, right? Represent the 14. I'm using 7 for the 40. 7 for the 40. All right, and let's put it here. Let's draw it. Bam. That's a 14. The 15 are bigger. But in the case where that do, if you draw that one, if it could fit right back with the same center. That's what's up. So you draw something like that. Let's show the dimension. We can maybe draw a line right here. And then draw a line right here. And then you saw this out 14 centimeters. 15 centimeters. That's what I want. All right? Concentric circle. All right, it says draw a cross-sectional view. I guess it's not the actual thing. I don't think 14 and 15 centimeters on this page. I don't know. We don't draw them inside that one. We have a concentric circle, the same center. All right? Draw one, draw another one. They have the same center. This one, 14. This one, 15. I want them to have the same center. Now, next question. It says the capacity of a container. It says show that the capacity of a container is this. Capacity of the container. So that the capacity is the volume to fill the inner space. But notice that the inner space, if I remember now, this thickness is still 1 centimeter. Oh no, it's 1 centimeter. But I say it was the thickness is the same throughout, and the thickness up here is clearly 1 centimeter, right? So the thickness is the same throughout. So it's a 1 centimeter. So the inner height of the container with the space is for it to fill inside here. You take 1/2 of that. So 119 centimeters. And the radius, inner radius is 14 centimeters. So using the 14 centimeters and then 119. So the volume, the inner volume, capacity is the inner volume. Capacity is the volume internally. So the volume internally becomes internal radius, internal area, pi r squared times the internal height. Internal radius is 14, right? But them so much use pi. So they say use pi 20/7. Good. 20/7. So this is 22/7 times the radius is 14. And the inner height is 119. Very important, you realize the inner height is 199. This is going to work out to 73304 cm3. Let's see. Let's work out it. All right, work out it. That's it. So the radio. Huh? All right. Our next question says, determine the volume of material used to make the container. So that's the actual material. So you have to do that, you have to do the outer volume minus the inner volume to get the material on it. Right? So this volume of material is going to be the outer volume minus the inner volume. Volume outer, external volume. And then the volume internal. So the outer volume has the outer dimension. So it's still pi, let's put capital R, and let's put pi r squared, let's put big H for the outer, for the overall height. Minus the volume internal is what we got up here. This 73304. 73304. This is 22/7. The outer radius is 15 squared, and the outer height is 120. We're subtracting the 73304. That's what they calculate. By the way, it's all for me. Huh? Give me the digit. 1 1 5 5 3. That's it. cm3. That is the volume. Total volume of everything and the volume of the space. What it says now, given that the density of the material is this, remember, this is not complicated. All this means is that 1 cm3 equivalent to 2.2 grams. All this means 1 cm3 is 2.2. 2 cm3 is 2 times this. 3 cm3 is 3 times that. 4 cm3 is 4 times that. Because the volume on this material is this, then the mass of this is this times that. Mass of this, right? So determine the mass in kilograms of the empty container, meaning the material. If you know the 1 cm3 equivalent to 2.2 grams. Therefore, the volume of the container is 11555. No, 11553. Yes, 11553 cm3 equivalent to 11553 times 2.2 grams. And I want it in kilograms. So we divide by 1,000 to get it in kilograms. And so what's your problem? How much? Give me the full score. I don't want to divide to get kilograms. 25417 grams. We divide by 1,000 to get a kilogram. So 25.417. Eh? 2.4 is supposed to have. Let me use them again. Oh, you divide the value here, we have by 1,000. What we do with that? What do we have here? No, so we have 11,553 times 2.25 401. Let's say 417. But this is the answer in kilograms. Divided by 1,000. I use move this 1 point to here. Divide by 1,000 to get it in kilograms. All right. Next question, number 7. So the sequence of figures is made from joining these shapes. We do this question another day. Maybe this topic will be discussed another day. Just with this topic, what should be comfortable with it. Draw the 4 shapes. Notice that these are broken lines, guys. Those are broken lines. So we'll add on the next shape. This is going to become a broken line. Eh? So it's like we're drawing back this shape first. We draw it. And then we move it out here. I'll put in the broken lines after. And then put in back another one on it. Like so. But this is supposed to be a broken line, this line. Let's draw this line broken. And that's a figure. But I got that. Nice and easy. This took a little bit thicker than it, but 6 is going to give you a mark. No problem. Pull up 4. Next part says, study the pattern of numbers in each row. Each row is one of the figure in the sequence on page 23. Some rows have not been included. Complete rows 1, 2, and 3. Let's look at the pattern. So these are the figure numbers. Notice that the figure number here plus 2. And it's 2 times the figure number. But you can see that 2 times the figure number. So this becomes n plus 2 plus 2. The really works out to be 3n plus 3. I mean, these are that's the perimeter now. A plus 3 relationship and a plus 3 again. Also the same thing again. Go up lines and out at it. Okay. That's equal that. That's equal that. And this equal that. Okay, so the same formula that we have used. Same formula. 2 plus 2. All right, let's fill this out for 6. We're setting this up. They become the 6 first figure, which is 6 plus 2 plus 2 times the first figure, which is 12. And you can write to them other place. So you can take the 6, jump it on this formula. 3 6 are 18 plus 2 is 20. Or you can add this up to get 20 plus 6. 20. Right, this 2 better. If you say 65, you can put the formula equals 65. You see what n is different. So from here, we're going to put the formula equals 65. We're going to put 3n plus 2 equals 65. Subtract the 2, we get 3n equals 63. Divided by 3, we're going to get n equals 21. So it is 21 right here. So then becomes 21 plus 2 plus 2 times 21 is 42. And this add up back to the same thing. That is it. Done. It says show that no figure can have a perimeter of 100. So all you have to do is try to work out what the n would have to be for the perimeter to be 100. N has to be an whole number. So if n is coming out to a number that is not a whole number, we put the perimeter formula equals 100, means that no, it can't have 100. All right? So remember now that n has to be a member of the set of natural numbers. Just capital N in natural numbers. Natural are counting numbers. Natural are counting numbers. All right. So I'm gonna try test. Formula for the number is this. 3n plus 2 equals 100. 3n equals 98. N would have to be equal to what? 98 over 3, which is not a whole number. What is your code? 32.67 or 32.7, which is not a natural number. We declare that n has to be a natural number of this. Not a natural number. Therefore, so. Right? So the perimeter cannot be 100. Therefore, perimeter cannot be 100 units. All right, that is it. Next question. Number 8, quadratics. Quadratics is a symmetrical function. The y value. Right? It's gonna easy. So I'm get these two values here so the same. Good after that, I can fill in everything. Outward from the symmetry. So this value going out towards the -5. This one must go out to -5 also. This value goes into 3. Into 3 as well. This is my symmetry. That becomes my symmetry. Right there. That point is my symmetry. And this is right after, right in between the values, right here. In between these two values, that's giving me the same y value. One is right in between those two. Remember also that the axis of symmetry is always the axis of the two roots. These are the two roots, you know, where the x value is, the y value is 0. So the average those two values, you're going to get this one in the middle. So this is your axis of symmetry. This represents your axis is, your symmetry, your vertex. This is a vertex. So the line of symmetry is x equals 1. The minimum value is 4. You can know that from the table just like that. You get me? It's one mark to fill over the table, you know. So I want to tell the examiner values are symmetrical about x equals 1. Right? So f of x values, f of x values are both equal 1. So right now, that's what I'm filling in. I use them somewhere from the paper and these arrows. For example, I can see how many style. That is it. All right, I want us to draw the graph naturally, most naturally. See there? So they put on some of them for us. I want us to draw the graph. Let's check the scheme. You see, we got point and maximum point. Maximum point. I don't know is maximum, but I'll screw to it negative. That's the between this. All the values are symmetrical about this point. What are some values that are missing? So this one, 2 units to it, you're gonna have a point 2 on the other side of it, right here. Right here. That's a point on it. See? 2, 3. It's a place of 2, 3. 2, 3. 2 place of 2, 3. Another point that we had to fit in was -2, -5. Because it is from this point. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 over to -5 down here. -2, 6. That's right. All right. Let's go again. Let's check again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's here. -2, -5. That's it. You need to talk about that regular. So draw a graph through those points. So these are the 2 points that we have to put on the table. Now putting them on the graph as well. Right? 1 point of here. Going down to each one. That's my graph. Not doing anything more. That's my graph. That's my graph. See there? The computer grid to all the points and draw the graph of the function. That's it. Next part. It says use the graph. Determine the maximum point. Determine the coordinates of the maximum point. It is 1, 4. 1, 4 is the maximum point right up here. If we use the graph, we're going to put this on the graph and put map. 1, 4. So examine see that I use the graph. 1, 4. So the range of values for which f of x is greater than 0. Now this is basically saying where are the y values positive? Right? We're talking about this part of the graph up here. Up here. That's where the y values are positive. Those y values are positive if the x value between these two x values is -1 and 3. That's when the y value is positive. F of x greater than 0 means that your y values are positive. F of x greater than 0 means that your y values are positive. Y values on the graph positive up here on the graph up here, so. And those y values are obtained for x values between this x value and this x value, between them. So all x values in between here are going to give you these positive y values up here. You can see. So the answer that they're looking for are the x values between these two values. Those x values give you those positive y values on the graph up here. So between -1 and 3. That's the answer for me. That's when x is greater than -1 and less than 3. That's the answer. X is between -1 and 3. Look here. If they are equal on this inequality right here, it means that I will be including the zeros where the function is equal to 0. I would have to put an equal on this and an equal on that as well. I'll be including where the f of x is equal to 0 on x. I don't want to. Next one. It says you must get a grade that x equal 1. So for to get the grade that x equal 1, you have to use the rule and draw a tangent at the point where x equal 1. And see another point that we pass through. It says determine the grade at the point where x equal 1. So we're going to go on the graph. So they don't set this off here. Oh, but x equal 1 is a turning point. We'll get there. We're going to be 0. Because at this turning point, your gradient, your tangent will go like this. Draw it in a different color. I'm going to get to enough calculate now. At x equal 1 is right here. Tangent is going to be a horizontal line like this. That's going to be a tangent. That line is y equals 4, which is 0. Horizontal line that was given that 0. That's like y equals 0 x 4, which is 0. Horizontal line. We bring that this point where x equals 1. So at this point, x equals 1, the maximum point. Tangent at that point will be that horizontal line. Grade of that line is 0. Right? Grade is 0. The gradient at the point where x equals 1 is 0. Tangent y equals 0. Horizontal line. Y equals 0. Y equals 4. Y equals 4 is 0. Horizontal line is y equals 4. Horizontal line passing through 4. The greater than horizontal line is 0. So the greater than the third line. Anything else? One other part. Like a linear program. This is Thomas make x buckles of juice and y cake x juice. X is the number of juice, y is the number of cakes. So let's say x juice and y cake. The supplier's customer, or Mr. Thomas, the supplier's customer, it must make at least 20 bottles of juice. At least 20 means 20 or more. The number of bottles of juice must be 20 or more. See, the x must be greater than or equal to 10. That's what that means. At least 20 juice. So x, which is the number of juice, must be greater than 10. And no more than 15 in the 15 is the max. You can make 15 or less. Not 40. It means that the number of cakes, which is y, at the left hand side of the 15. That is simple as that. It says, y is equal for this information here. Number of bottles must be at least 20 means 20 or more. The number of cakes must be no more than 50. No more than 15 means 15 is the max. 15 or less. Can't pass 15. This is it. What about that? So that's two inequality. Next part says, each day Mr. Thomas uses $160, $160 to make the juice and the cake. Remember, is making juice and white cakes. He says the cost to make the bottle of juice is $3.50. The amount paid at $3.50 now times the X. And the cost of making the cake is $5.25. The amount paid is $5.25 times the Y for the total money that he's spending. And he can't spend more than 163. So the total that he's spending is going to be 163 or less. So it's 350 times X or 3.5 times X. That's money for the juice. Plus 525 times Y. 5.25 times Y. That must be less than or equal to the amount of money that we have. 163. That's unequal for that one. Total money that is spent can 163 or less. Put on a 0 upon this, 3.5, 0 here, so fine. Gotta go to that. That okay? That is equal for that one. Next one says, show that on any given day it is not possible for Mr. Thomas to make 50 bottles of juice and 12 juice. So in other words, you have to show that money is spending to make 50 bottles and the 12 is not enough. I can't pass it. Remember now, what is what? Oh, he's a farmer. Yes. This is the money I'm spending. This represents the money that we spend. This. You can talk to this guy. This is the money I'm spending. That's the money that he's spending. This is his spend. And this is x. This is when x equals 50. This is y. This is when y equals 20. They're plugging them in the spend to see what the spend is going to be. The spend would be 3.5 times 50 plus 5.25 times 12. Remember, the spend has to be less than 163. Let's say equal to 163. What is work out to? What is work out to? That's spend. Huh? 238. This is 238. 238 is greater than 163. And therefore not possible. See that? So you can say something like $238. It's a $238 amount. 238 is greater than the limit of 163. And but the most you can spend is 163, you know. Therefore, not possible. But the amount that you need is 238. Right? You make that not possible. Because you can only spend one. The amount that you're spending right now is more than the amount allowed. 163 is the amount allowed. This is the amount allowed. The maximum amount that we can spend. The maximum amount. The maximum spend. And you would spend 238 in order to do the 50 views. Yeah. I'm gonna pass the maximum. Understand that? Over where you want to present. So that's what is that. All right. Next question. I'm going to give you an assignment. Make sure to do that. You guys need to be doing work every single day now until the exam. Every single day you need to be doing work. I'm going to 2 papers to do before Wednesday. Remember our class tomorrow evening again, going to the other 2019 paper. I'm going to 2 papers to do before Wednesday and Thursday. We have class Wednesday and Thursday. We have class face-to-face Wednesday, Thursday and Wednesday. This question says, the diagram below, not drawn to scale, shows a circle. Points PQRT and V are on the circumference. QRS is a straight line. No, this straight line is not a tangent. I cross through the circle. So we don't have no tangent in this. So we don't want anybody to talk about no tangent and nothing in this one. That's not a tangent. So this is not a tangent and chord angle. But understand that. Good. It says the angle out here is 75 degrees. And the angle out here is 60 degrees. All right. It said determine each of the following angles, show detail work when necessary, give a reason to support your answer. First angle I want is angle PTR. That's the angle up here, so. Remember, an angle is subtended by an arc or a chord. When you find what the subtended angle, come back along the lines forming the angle until you reach the circumference. An angle is subtended by an arc or by a chord. So this angle up here, so you want. You come back along the side until you reach the circumference here and there. So that angle is subtended from those 2 points on the circumference. I don't see a chord there. So it is this arc that is subtending that angle, this arc. Or if you like, you can put an imaginary chord in there if you want. That arc in blue is also subtending this angle up here. You can see it is also subtending this angle up here, which is 75. And if I put in the chord, these 2 angles are in the same segment on that side of the chord. So those 2 angles are in the same segment subtended by the same arc or by the same chord, so they are equal. So this angle is also 75 degrees. Same segment rule. All right? Simple. So this angle here equals 75 degrees. Because angles in the same segment are equal. Angles in the same segment are equal. This angle here is 75 degrees. Let's put another eye. Next question says, angle TPQ. TPQ. TPQ is this angle that one. Right here. When I look at that angle, I can see that it is opposite this one in the cyclic quadrilateral. That's a cyclic quadrilateral. Those two angles are equal. Those two angles are supplementary. These two are up to 180 degrees. Opposite angles. And this angle here says 60. That's a straight line. So this angle inside there, so it's 180 minus 160, which is 120. And then if this is 120 and these two must add up to 180, means that this over here is 62, don't it? But it's a simple rule that you can actually use for this. To see that that angle is 60. Let me show you. Exterior angle of a cyclic quadrilateral. So that cyclic quadrilateral you're looking at in red. But take this side and extend it out here, draw it in blue. Then this is an exterior angle of that cyclic quadrilateral. This angle out here. But take one side and extend it and form an exterior. I want to see it better if I put it in red. Put it in red and see if I see it better. But take this side and extend it out here. And complete the angle with the adjacent side here. Then this angle is an exterior angle of the cyclic quadrilateral. Exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So the angle here equal to opposite angle across here. So this equal that over this. So the exterior angle of a cyclic quadrilateral is equal to opposite interior angle. Other way to work it out. Total angle 9 years 180. Inside here, so is 120. And then these two opposite angles are 60 again that way. That's the other way to do it. All right? So that is this. This one equal that for 60 degrees. What's it on here? This angle equals 60 degrees because the exterior angle of a cyclic form equals the opposite interior. That's why that only 60 degrees. Next question. It says the obtuse angle POR will hold the center of the circle and they don't show the center. If I'm in the exam, I'm going to put in a center. Look at these out. So this angle right here is 60 degrees. And they don't show me the O. So I put in an imaginary O. So this is like a diameter right here. And a diameter right here. So I'm put O right here. So. Put O like right here. O. So it's alone with it. Asking for POR. P to O. That could be an angle at the center. So from these 2 points, which is now this R. or an imaginary chord. That imaginary chord would be subtending the 75 degrees of rotation. Same chord must subtend twice as much of the angular center twice as much of the angle that I want to have is 150. You can take this angle that I want to have angular center twice angular circumference. Both of them subtend by that R, that's the 4. Angular center is twice angular circumference. I'm thinking about all right. Angular center twice angular circumference. So the angle is 250 degrees. 150 degrees. This angle is equal to 3 times 75 degrees. Is equal to 150 degrees. The reason is angle center. Angle at center. Twice. That's it. Come after that. What else? Done. Now, this question have a mistake on it. That have S1 is and S2 there. You have mistake because you said that the angle S1, angle of the person S1 is 12 degrees. So clearly, it's one of the lower. The angle of the person this are 12. 12 has to be S1. That is good. That I'm the wrong way around. But that happens sometimes. Don't pick it up. I don't know what's it. But this is supposed to be. Alright? Correct. These are supposed to be. You can reading up information. The question said, a person at the top of a lighthouse TV. So this is a lighthouse, and somebody's at the top of the lighthouse. These ships S1 and S2 approach the coast as illustrated diagram below. Angle of depression are 12 and 21 respectively. This 12 corresponds to S1. This 20 corresponds to S2. Remember, angle of elevation looking down, angle of depression looking down, equal angle of elevation from the other end looking up. And just speaking, angle of depression angles are usually outside the triangle, angle of elevation angles are inside the triangle. We tend to do that transfer sometimes. So that angle of depression down to S1 is this angle looking down here. 12 degrees. Angle of depression down to S2 is 20 degrees looking down here, 20 degrees. Down here, 20 degrees. The angle in between here, between two of them, is 12 minus 20 minus 12, that's 8 degrees. Right inside here, so the angle is 8 degrees. With these two lines, that's 8 degrees, 20 minus 12. The angle down here so is also 12, and down here is also 20. You can put them in as well. As angle of elevation looking up now, just forming a Z. So the Z here. When it's at 12, then it's at 12. Similar with the 20. So the Z here, the 20. It's at 20, it's at 20. So just remember, angle of depression looking down equal angle of elevation looking up from the other end. So inside it says 12 degrees up. Inside it says 12 degrees. What's going to say? Ships are 110 meters apart. I mean that this distance is 110. Let's put down in blue. This distance is 110 meters. Now, if you're going to work in this triangle, which is not a right angle triangle, you're going to have two high rules. If you this case, we can use the sine rule because these two sides and angle are opposite each other, you know, both of them. You can use sine rule in that triangle for whatever you want to do. All right? And that's what I want us to come. First question says, determine the distance PS. PS is this side. Here, that side. We're going to use sine rule to find that side. Let's call this side X so we can reference it. Let's just call it X. The distance here, we're going to call it X. We're going to use sine rule. We're going to be using this angle with this side, this angle with this side. See that? Sine rule. Right, so we're calling that side X. We're going to say sine rule for X. Sine rule. We're going to do X over sine of the 12 degrees, which is opposite the X. Side over sine of angle opposite. Equal the side that you know, which is 110, sorry, over sine of the angle opposite the 110. Take this now, multiply up here and get the X. So the X is going to be 110 times the sine of 12 degrees divided by the sine of 8 degrees. Put that in the calculator, I will get that X is that distance. Fraction 110 and the sine of 12. Make sure you calculate. Yes, it's calculated in degrees, but can't keep up here. That is as in degrees. Over sine of 8. Sine 164. Key significant figure 164 meters. Yes, 164 meters. Put on the diagram. So this distance is 164 meters. So the X up here, 164 meters. All right. One of the hypotenuse in this right angle triangle. So again, so-called to in this right angle triangle, which I'm sure that's what we're going to be doing next. See? Yeah, the height of the lighthouse. We're going to work the height of the lighthouse working in this triangle now. We're going to be using sine of the 20 degrees. But for this 20 degrees now, the height of the lighthouse is the opposite. That's the hypotenuse. So sine of 20 degrees equal to over 160. So we're going to use sine 20 degrees over 164 hypotenuse. So 164 multiplies up here with PB. So PB equals 164 and the sine of 20 degrees. Put that in the calculator. So this will be 164 and the sine of 20 degrees. 56.1. 56.1. Done. Last question. The assignment I give the students online the assignment as well. Not just for those in it. Nature seeds. I don't think I need to practice. There was P, Q, and R. Those three nature seeds. Like a 2 by 2, 2 by 1, 2 by 1. He said, using calculation to support your answer, explain why the matrix P is explain whether it's a singular or non-singular. So to do that, you have to find the determinant. Remember, the singular is the one that has no inverse, determinant equals 0, right? So for the singular matrix, it has no inverse. Because the determinant will be equal to 0. Determinant will be equal to 0. So the determinant is singular or not, you need to find the value of the determinant, right? Talking about P. So the determinant of P is equal to this product minus this product. Clearly that is not 0. It's 5 times the minus 1. 5 times minus 1 minus this product is 2 times 0. 2 times 0. That is negative 5. Negative 5 is not 0. Therefore, P is not singular. That's an inverse. The 5 is not 0. That's an inverse. It's a non-singular matrix. 5 is the determinant is not 0. All right? That is the first concept. P at the equal count. Let's write them down and calculate. Let's write them down. So the P is minus 1,205. 2. And then R is 1115. Copy them down. Watch this now. You want to develop A and B right here. You're really trying to find the Q, don't you? So if this is a matrix and you want to find Q, you're going to transfer the inverse of P in front of that. So based on this, the Q is going to be equal to P to the minus 1 times R. So that this is the matrix equation. And since you want to find Q you're trying to find, you put the inverse of P in front of the R. Simple as that. So the Q, which is AB, equal to the inverse of the P. So we can put it inside here still. It becomes 1 over the determinant. Inverse of P is 1 over the determinant. Let's write it. P to the minus 1 is 1 over the determinant of P times the adjoint of P. And this is what we're going to calculate here now for the minus 1. We work with the determinant already, it's negative 5. We did it up here already, so we don't have to calculate again. It's negative 5. So it's 1 over negative 5 times the adjoint of P. The adjoint of P is up here by interchanging these two. Leave these two where this 2 become negative 2. This 0 don't count a sign, so it stays 0. This right here is just our P to the minus 1. This. I have to multiply by R now. R, remember, is the matrix 11, 15 right here. 11, 15. That's the R. I always say, work out this first and leave the fraction for last. Negative 15, 1 over negative 5, sorry, times the column matrix we get from multiplying these two. All right? So multiply the root is the first. The root of this matrix times the 1 column. You're going to get 2 values in this matrix. This first value is positioned in the first row and the 1 column. So to get it, to multiply this first row by this 1 column. Multiply them first element times first element, second element times second element. First element times first element, second element times second element. So it's 5 times 11 and minus 2 times 15. Now the 5 times 11 is 55. And minus 2 times 15 is negative 30. So this second value is positioned in the second row, 1 column. So we're going to multiply this second row by this 1 column to get it. Same way, first element times first element, second element times second element. First element times first element, second element times second element. 0 times 11 and minus 1 times 15. 0 times 11 is 0. Minus 1 times 15 is negative 15. And this therefore reduces to 1 over negative 5 times. This becomes 25. It becomes negative 15. And dividing each of these values now by this negative 5. So 25 divided by negative 5 is negative 5. Negative 15 divided by negative 5 is positive 3. That's AB equals that. Question asks for the A and the B value. You cannot leave the matrix as the answer. You have to explicitly state what the A is, what the B is. So the A is equal to this negative 5. The B is equal to this 3. So A equals negative 5. B equals 3. Very good? Nice and easy. Next question. State the reason why the matrix product is not possible. It means that it's not conformable. The number of columns is first, is not the number of rows in the back. So let's write it down and show them. So the Q order, Q is which one again? Q is this one, it's a 2 by 1, right? Q is a 2 by 1. So that's about 2 by 1 times, and the P is a 2 by 2. By 2. P is a 2 by 2. So these two, this number of columns and this number of rows are not equal. That's the symbol says it tonight. And you can state it. Number of columns in Q not equal to number of rows in Q. Right? State the reason. The reason is that number of the column in the first matrix, if you know it's Q, is not equal to the number of rows in the second matrix, is Q. That's the reason. Done. Next question. Vectors. OABC is a parallelogram, means that the opposite sides are equal vectors. Like parallelogram question, because the opposite sides are equal vectors. It says X is the midpoint of AB. And look here, them start the points for you. OA. It means that you have to continue around the object. You can't put B down as well. You can't have O, A, B, and then C. You have to maintain the orientation. So since you put A right here, so if they're going this way, this has to be B. And this has to be C. But understand that. Everything important. You have to maintain the orientation. Good. So they say now X is the midpoint of AB. That's up here. Let's put on the X in red. So right here in the middle of it is X. And Y is the midpoint of BC over here. Right here says Y. Then it says OA is R. So this vector is R. Let's put it on. This vector right here is R. And OC is S. That's across here. It's right here. So it's S. Remember now that this vector up here is the same as this vector up here. Everything is also S. But this is the midpoint. It means then that right here is half S and right here is half S. Let's put them on the diagram. More information about the diagram, the better. Relevant information. So this is half S. Half of S. This is half of S. Similarly, this side and this side are equal vectors. So all of this is the same as vector R. But then Y divides is half an R. So it means that this little piece right here, so is half R. This little piece right here is also half R. Let me write this Y. I put this small. This point Y. All right, so this is half R up here and half R down here. So all information we need now. You can see over from point to point. This question says, given that OX plus OY is equal to this, your K is a constant. Using a vectors method, find the value of K. Find the value of K, all we need to do is work out what this is really. And we're going to see what the R is. Let's work out what OX plus OY is really. So we need an expression for OX and an expression for OY in terms of R, so we can see what the K is. All right, so work out what they are really, and we're going to see what the K is. So OX plus OY equals, now, what is OX? See here, OX. That is to go from O to X. Easy. Is R plus half S. But can see that? Go from O to X. You're going to go this R up here plus half S right there. So the OX is just R plus half S. This part of it is the OX. Plus the OY now. So Y there, so go from O to Y. I'm going to go S plus half R. S plus half R will take me from O to Y. Simple as that. S plus half of R will take me from O to Y. Consolidate the values. So this is a R and that's a half R. That's 1.5 R, which is 3 over 2 R. So you have 3 over 2 R. Then this is half S and that is S. Again, that is 1.5 S. That's 3 over 2 S. So those two add to 3 over 2 S. And try to work towards this expression. So you're going to factorize the 3 over 2. That is a common factor. Anything. Okay, the common factor. This is 2 over 2 into R plus S. And if this is equal to that, you can say that K equals 2 over 2. But you can say that? We can say, therefore, K is 2 over 2. That is the answer. End of this step. And that, another step. Go on, where is it? 1.5, same thing, same as 2 over 2. I've moved 1.5, same thing. Okay, back to it now. End of this step. And that is that. Is that. All right, guys. Online and in the classroom. I'm telling you your assignment. I'm going to send 2 papers in the group. Remember, I come back to class tomorrow for the other paper, you know, at 5 p.m. at 11 a.m. Remember, tomorrow's class is Easter Monday. We have class at 11 a.m. So, no excuse for not come class. I suggest that the people doing SBA want to spend a couple hours today and do some work on SBA, and tomorrow the SBA have to finish 3 p.m. tomorrow. So not for work on it, you can't finish itself. So I suggest that the people doing SBA do some work today and do some work tomorrow after class, before and after class. Finish the SBA. I have to get it 3 p.m. tomorrow so we can upload it to CSEC. Otherwise, that's 0 now I get. If you get 0 in SBA, you can't pass the exam. If you don't submit the SBA, you can't pass the exam. I'm going to depend on that. It has to be finished. But listen now, we're going to be working on the next paper tomorrow. We're not done yet enough work out and tell me what you're going to get from it, you know. 55 are the pass mark. Come on, how much you're going to get. You know, tell me if you don't come back to my class. Come on, how much you're going to get. Not a joke thing. Work it out and tell me what you're going to get. All right. So I'm going to send a paper. I'm going to send a paper in the group. You have to do both of them before Wednesday. So the 2 papers before Wednesday. You hear me say? Finish the 2 papers, send them to me, let me see some of them before Wednesday. The whole paper. I'm going to send them in the group just now. It's 2 past paper. 2 past paper. 2022 paper. January and June 2022. Finish 2 papers, someone please. Work them out from on the head. No look on nothing. I know it's a solution there all over the world available. Work them out. Be honest to yourself. Work them out. Send them to me, please. 2 people, I'm going to send them in a group just now. Remember, tomorrow at 11 a.m. we have a class. Again, online for the other paper. All right, so that is it. See you guys. SBA people, let me hear what's happening. All right, students online, you got the instructions. Right, Brandon? Jadine? Samuel?
Yes, sir, I got it.
Yes, sir.
I'm going to send the papers in the group right now. Make sure both of them are finished for Wednesday. All right, bye. I'm going to end the session now.